Hello friends, welcome to Aravalli Geo Academy. Hope you are well. So in this video we will discuss the next part of the atmosphere. We have already covered the origin of atmosphere, what is atmosphere, and composition of the first atmosphere and composition of the second atmosphere, and composition of the present atmosphere. After that we have done the uh, layer of the atmosphere, and we have covered troposphere. Okay, and this was our last point. The bottom of the isothermal zone mark the top of the troposphere. Okay, this was our last point. So in this video we will discuss the next layer of the troposphere. Okay, above the troposphere. So stratosphere lie just above the troposphere. Okay, and the boundary between stratosphere and troposphere is known as tropopause. Okay, this is the boundary between troposphere and stratosphere, known as the tropopause. The tropopause height vary location to location and season to season. Okay, the height of the tropopause vary location to location and season to season. Like at the equator, the height of tropopause is the highest. Okay, height of tropopause higher at the equator and lower toward the polar region due to the temperature. Okay, at the equator temperature is higher, the height of the tropopause is highest, and at the polar region temperature is the low. Okay, so height of the tropopause is the low, and tropopause height also vary season to season. Like in the summer season, the tropopause height is the higher, okay, as compared to the winter. In the winter season temperature is low, so height of the tropopause is the lower as compared to summer season. Clear now the both point about the tropopause. uh, in the some areas, okay, at the tropopause, okay, due to the breaking of this tropopause, actually jet stream is responsible for this breaking of the tropopause breaks and causing the mixing of the stratospheric and tropospheric tropospheric and stratospheric air. Okay, due to this breaking of the tropopause, tropospheric air mixed with the stratospheric air. Okay, and why this tropopause is break? Due to the jet stream, due to the presence of the jet stream. This break indicate presence of the jet stream. And what is jet stream? Actually jet stream are fast moving air current flowing through the atmosphere in the narrow path. Okay, so in upcoming videos we will cover the type of jet stream also. Okay, uh, different type of jet stream and effect. Okay, and all property of jet stream. But you remember, okay, jet stream are the fast moving air currents flowing through the atmosphere in the narrow path. Okay, and due to the presence of this jet stream, this stratopause sometime break. Okay, and due to this breaking, tropospheric air mix with the stratospheric air. Okay, uh, remember about the jet stream. Jet stream wind can exceed the 100 knots. Knot is the actually unit of the speed. One knot equal to 1.15 mile per hour as well as 1.85 kilometer per hour. Remember this point. Okay, this is important for the part B, because factual questions come in the part B. Okay, and conceptual questions come in the part C in CSIR-NET. Okay, so in the stratosphere, air temperature increase with height. We know that the temperature in the troposphere decrease with height, but in stratosphere temperature increase with height, creating the temperature inversion. Okay, inversion it means reverse, because in the troposphere temperature decrease with height, but in the stratosphere temperature increase with height. So this condition is known as inversion. Okay, this why this inversion happening here? Okay, the inversion and isothermal layer limit the vertical air movement from the troposphere. So due to this inversion, uh, the isothermal layer limit the vertical air movement. Isothermal it means equal temperature layers, because we know that at the bottom of the stratosphere, that at the bottom, or we can say at the top of the troposphere, the air temperature is around -60. Okay, and in the stratosphere temperature is increasing. Okay, so this dense tropospheric layer cannot move upward. Okay, uh, because temperature is high, actually warm in the stratosphere. Okay, so the inversion and isothermal layer limit the vertical air movement from the troposphere, because troposphere layer is the more dense as compared to the stratosphere. So dense layer cannot move upward. Okay, so this inversion prevent the vertical air movement in the stratosphere. Okay, from troposphere. Vertical moisture within the stratosphere is also reduced, making its stratified layer. Okay, because temperature is continuously increasing. Okay, temperature actually increasing -60 to 0 degree only in the stratosphere. Okay, but at the bottom of the stratosphere temperature is in the minus. Okay, or at the top temperature is a 0 degree. So stratified layers are formed at the top part. The temperature is higher, so warm airs lie at the top part and cold air lie in the bottom part. Okay, so this type of stratified layers form in the stratosphere. Why the temperature is increasing in the stratosphere? Due to the presence of the ozone. Okay, actually ozone absorb the heat, absorb the ultraviolet ray. Okay, due to this absorption temperature is continuously increased. Okay, ozone cause the temperature inversion by heating of the stratosphere. Without ozone, the stratosphere would be likely cool with the height like the troposphere. So if ozone is absent in the stratosphere, then temperature simply decrease like the troposphere. Okay, temperature is cool with the height, temperature is not changed with the height if ozone is absent. So the maximum ozone concentration occur near the 25 kilometer at the middle latitude. This is the condition of the middle latitude. At the middle latitude it means beyond 30 to 60. Okay, between 30 to 60 degree latitude, north or south. Okay, so in the middle latitude, near the 25 kilometer, ozone concentration is the maximum. Stratospheric air temperature peak around the 50-kilometer altitude, because this is the maximum height of the stratosphere. Stratosphere height is very between 11 to 50 kilometer. So the temperature, the maximum temperature around 50-degree altitude. Okay, so air at the 50-kilometer less dense, because temperature is the maximum. Okay, if temperature is high, then air density is less. Okay, so air density is at the 50-kilometer is less dense as compared to the bottom of the stratosphere. So absorbs solar energy, heats fewer molecule more intensely. Okay, most solar energy is absorbed in the upper stratosphere, not reaching at the ozone maximum level. Okay, because upper layer is a more lighter. Okay, so more energy actually absorb this lighter air, not reaching at the ozone maximum level. Energy transfer downward is slow due to the low air density at the high altitude, because the upper air is the less dense. Okay, and this receive all energy, so downward motion of this energy is the low. Okay, despite increasing temperature with height, the air at the 30 kilometer is extremely cold, because temperature is very -60 to 0 degree now. So around the 30-kilometer height, okay, the air is extremely cold, around -46 degree centigrade. At this altitude, temperature over polar region can vary greatly week to week. Okay, temperature is vary in the polar region week to week, but in some area, the sudden atmospheric warming can rise the temperature by over 50 degrees centigrade just in a week. Okay, this is the actually unique case. Okay, in few areas the stratospheric temperature suddenly increase around 50 degrees centigrade just in a week. Okay, and this phenomena is known as stratospheric warming. Okay, but about this phenomena, okay, this is the actually not fully understood. Okay, research is ongoing on this topic. So due to this sudden atmospheric warming, this sudden atmospheric warming can influence the weather pattern for the week across a large area. Okay, now next layer is the mesosphere. Okay, mesosphere just lie above the stratosphere, and the boundary between this mesosphere and stratosphere is known as stratopause. Okay, and this stratopause located just above the 50 kilometer or around the 50 kilometer. Okay, and temperature of this stratopause is 0 degree. Remember the temperature also. The air at the stratopause is extremely thin because temperature is the maximum here, 0 degree around, and stratospheric pressure is air around 1 millibar, because we already know at the just above the 32 kilometer or just below the 32 kilometer 99 atmosphere is lie. Okay, just above 32 the only 1% atmosphere is there. So atmospheric pressure here average around 1 millibar only. Only 0.1 percent of atmosphere molecules are above this level. Okay, above this stratopause. 99.9% of atmospheric mass lie below the stratopause. Nitrogen and oxygen percentage in the mesosphere are similar to sea level. This point is very important. Okay, because we already know the atmospheric composition is actually similar in the up to 85 kilometer height. Okay, this zone is known as homosphere. So the nitrogen concentration and oxygen concentration in the troposphere is 78 and 21. So this similar proportion also present in the stratosphere or mesosphere. Okay, but percentage in the mesosphere is similar to sea level. Air density in mesosphere is very low. Why this air density is very low, and why air density is high in the troposphere? Why not in the mesosphere? Because we know that uh, the nitrogen and oxygen concentration is similar to the troposphere in the mesosphere, but air density is low. Why? This is the actually conceptual point. Because in the mesosphere volume is increased. Okay, as compared to troposphere the volume of mesosphere is high, so air density is the low in the mesosphere. Okay, remember this point, why density is low in the mesosphere. Because we know that the concentration of nitrogen and oxygen is the same to troposphere, but air density is low due to the higher volume. Okay, breathing in this provides such less oxygen per breath because volume is higher, but oxygen percentage is same as compared to troposphere. But due to this higher volume, oxygen is actually less. Okay, so breathing this air provide much less oxygen per breath. Okay, so due to the lack of the oxygen, we can get the hypoxia. Okay, this is the lower oxygen conditions or oxygen starvation of the brain. Pilot fly above 30 km without oxygen risk hypoxia. The mesosphere poses several dangerous effects on the human body. In the presence of the ultraviolet radiation can cause severe burn on the exposed skin. Okay, and at the such low pressure, blood would boil at the normal body temperature because pressure is very low, around the only 1% atmosphere lie in the mesosphere. So in this pressure conditions, our body, our blood is boiled. Okay, air temperature in mesosphere decrease with the height. Okay, this is the factual point, and this cooling is partially due to the low ozone concentration, because ozone is absent in the mesosphere, so temperature is decreasing with the height. Okay, and less ozone means less absorption of the solar radiation. Okay, ozone actually absorb the solar radiation, so less ozone in the mesosphere, it means less absorption of the solar radiation. It means temperature is not increased with height. Molecule lose more energy than gain, causing the cooling. Why temperature is cooling here? Why temperature is decreased? Because molecules lose energy more as compared to the gaining, and the temperature keep dropping with the height up to the about the 85 kilometer. Okay, this is the maximum height of the mesosphere. At the 85 kilometer, the atmosphere hits its lowest average temperature, minus 90 degrees centigrade. Remember this point. Okay, examiner directly ask you uh, actually lowest temperature achieved in which at which height or in which layer. So in the mesosphere or at the 85 kilometer, or what is the temperature here? Minus 90 degree. Okay, this is the lowest possible temperature of earth atmosphere. Okay, so this is the all about the mesosphere or stratosphere for my side. In next part we will discuss the thermosphere, ionosphere or exosphere, and you try to share this video those are preparing for CSIR-NET or SET exams. So thank you so much. If you have any doubt, then drop a message in comment section. Okay, I will explain. So thank you.